Hi everyone, welcome to Studio LINKIT. I'm here with a beautiful panel of beautiful experts and I'll introduce them to you in a second. But first, my name. I'm Lieke, I'm an event manager at LINKIT and I made sure these people are here for you. And well, I can't wait to know a lot about data because I do not know enough about it to keep talking for an hour. First of all, I would like to introduce you to our moderator who will be handling this session and making sure all the questions you send in at home will be asked to our panel.
Hi, good afternoon. Thanks, Lieke, for the introduction.
That's it, okay, nice. That was Gino, and if you have a question, you can send it in, and Gino will make sure that we know about it, and one of our experts can tell you more about it, which is why we're here. And I would love for you to all introduce yourself, and I would like to start with you, Celine.
Yes. First of all, thanks for organizing this nice event. And yeah, I'll shortly introduce myself. I'm Celine Günger. I have a background in computer engineering and software engineering. And I have worked in various industries, in industrial automation, finance, e-commerce, and also service management, and also consultancy. And currently I'm working as a data engineer at ING in the digital sales and customer interaction department. We make sure that customers are getting the best experience by driving innovative predictions from using analytics. And so I'm also helping to build and building productionization of the machine learning models. And I have been involved in almost every cycle of software processes like design, development, requirements gathering, testing, and deployment, and monitoring on production and maintenance, of course. And so this is me in a nutshell.
Nice. It's your turn.
Hello everybody, my name is Gerrit Bos. I'm currently a director at Zanders Consulting, looking after data analytics. I've been in modeling data analytics for the last 20 years or so, in various roles, both on the consultancy side, but also within the organizations, trying to get models delivered, data sources embedded, and ensuring that we get the models productionized. I'm very passionate about data and models, to be perfectly honest, right? I do think I've got the slogan data for good, so I do think where you use data appropriately and in the correct way and apply models on top of that, not only can I think help organizations to derive additional profits, but also help the individuals and the customers. So mainly been in the financial services industry, but also within quite a lot of other industries in the marketing role, with insurance, etc. So looking forward to having a chat today with you guys.
Nice.
Cool.
Me too.
Yeah, it's okay, cool.
And then on my left side, I have Aliona.
Yeah, Aliona Gareva, one of the principal AI and data engineers at LINKIT. So here I have my colleagues, even more than one or two colleagues. Mostly doing a lot of engineering around AI. So literally not a data science, it's a little bit different. So mostly making sure that all the beautiful models created and delivered by analysts and data scientists are eventually productionized. So the business and end users can get value out of it eventually. In my spare time, I do non-profit Spy Ladies Amsterdam. It's not about pies, it's about coding in Python. So we're running workshops every month. And despite the name, we're open for everyone, but we're encouraging female engineers and non-binary engineers to give different trainings and sessions.
Very nice.
And also a Microsoft AI MVP. So it's a program for most valuable professionals that work with specific topics. In my case, it's Azure Machine Learning. Or Azure Cognitive Services. That's how you can get this award eventually. I think that's it from my side.
Nice.
Awesome.
All right, thank you very much. Very clear. And I think we have a broad panel, so we have a lot of questions. I have them all in my hand, so I'm ready to attack you with these questions.
Pack, right?
Yeah, it's a thick one. Let's see if we can get them all. And let's just start with the first one. What is the business value of a model and how do you get everybody on board? Because I believe it's not something you just start, you just jump into.
Yeah, I'll maybe take that one. I think it's a really good question, and I think it also depends on what you talk about when you mention model. I think there's different uses. I think there's a data model, which is basically the data infrastructure that's kind of built, and then you kind of have the statistical model that sits on top of that. I think both of them are incredibly important. I think we've seen throughout organizations where models are being implemented, and it's adding quite a lot of additional business benefit, and I think that's where the world's moving to as well. I do think from my side, I'm more on the modeling side, the statistical modeling side. The data model is incredibly important in that. So I think it's kind of the story of garbage in, garbage out. So if the data is not in 100% correct format, you're not going to get the model. And I think more importantly, you're not going to answer the business question, because the model needs to have a purpose. There's a kind of business challenge or business question that needs to be resolved. If the data is not representative or accurate or time years, you're going to run into issues. And I've kind of seen that throughout my career. If those things aren't working, whatever you've built the data on or the model on in the data warehouse, and suddenly implementing it in the production environment, and those two aren't matching right, then there's a few issues, right? So even need to have there needs to be some redevelopment and time to market for the models delayed. So it's incredibly important. So I think that the statistical model answers the business question, the data model supports the statistical model, and that's I think if those two are aligned, you can have a really good practical model. And I think that's where a lot of organizations struggle with as well, to be perfectly honest.
Yeah. And what's the struggle that you think comes up most?
Well, that the data is not aligned, right? So the data that's in your, it's called sandbox or development environment, for some reason doesn't match for when you're going to implement it operationally. I think that's in my mind one of the key challenges that we do have.
I think that's a very crucial part, to have same data as on development and also production, and also on the test environment as well. When data scientists and they're working on the modeling, and they're seeing predictions, and they're testing all these scores, and that when you move to production, sometimes it's all different. So this is totally like a waste of time, actually. So then it's very important to have the same data and equal on production and development environments. Yes,
definitely.
Yeah, definitely. And it's hard because it brings up struggles, because I hear all of you laughing. Some things are making. So how do you make sure that people are not like taken aback? So no, it's too much struggle, or we're not going to do it. How do you get everybody on board?
Well, I think firstly it comes from business, right? So I think whatever the business question is and the business stakeholders, they need to be brought into that. But throughout the development of, let's call it the statistical model, I think it's becoming more and more important to get the data engineers wrapped right up front in that process. Because otherwise, I think we run into those challenges where the statistical guys think, this is really cool, and they build their models, and then we get to implementing it, and it's sometimes a bit of a disaster. So if you get the data engineers up front in the process, and they continue with let's call it the data scientists or modelers throughout that process, and once you implement it, hopefully most of those things have been resolved, and you can get that model deployed in a practical, accurate type of way. That's kind of my view. I don't know if you guys have other views, but
definitely. I think data intensity and data gathering is also a very crucial part of the starting a model development model. You need to make sure that data is available, and data intensity is also enough for making good predictions, actually, to correct predictions, most importantly. So that's a very important part.
Yeah, and for me it's also a process. I know that there are always like some strict deadlines and everything, but what I see really, really often, especially with data science in financial industry, because of all this, like a lot of limitations, regulations, and everything should be taken into account, you're actually getting in the situation when you're sitting too long in a sandbox. When you call it like proof of concept, and then it goes straight to production. So nobody even dared to test whether this data will be available on the production level. Is it possible to get them? So literally like this huge, I would say, gap between different environments, and they say, we're not capable of having the real data in the dev environment because it's not secure enough. So that's why we're not, like, there is no literally We are not allowed to have this real data in development environment. That's why you're doing things, but you don't test it fully.
Yeah.
And I would say the hardest part in the whole story, like of the modeling story, so with the typical software, you know at least what to expect, you can test it somehow in the sandbox, and then literally anything that could change, it's only if you're going to change a part of the software. With models is different, they're not static. So if you change something, if the data are changing, the model will be given completely different predictions. And I think the good example of it is exactly COVID situation. When it started, a lot of models just went like crazy. And that's again because there was no mechanism to monitor it properly.
Yeah.
And it was no time to go step by step from proof of concept to more like MVP to test it end to end, whether it's possible, if you want to have real time or batch or whatever way it is. So we go just like jumping straight into the
Yeah.
I agree. I agree.
I
Yeah.
agree too. Yeah.
And then you get at the end you get disappointed stakeholders.
Yeah.
Because you work on this 1 year, why on earth you didn't deliver anything?
Yeah.
And then you also like let's say hearing from IT people, for example, that sorry, but unfortunately we don't know what it is. We never used to work with such things. We were thinking that it's just like test this and that's okay. How it couldn't be like 100% accuracy, like how on earth is it even possible? So let's say to sum up, I think let's say the data will be the core for everything, literally. Because if the data is not correct, if the data not there, if the data not representative enough, you will face a lot of issues.
Yeah.
Yes.
Definitely.
Yeah. Yeah, I think that's very clear in all of your stories.
Yes.
And then I have a question, and there's also a question from the audience, and I'm going to ask this one very fast first, and then we'll skip to that one. Because I also got a question, do you need big data while making a data model? Because you're all talking about having the data, using it right. Where does it come from?
I would say it depends.
Yeah.
It depends on type of the question you need to answer eventually. Because usually how it's not starts like the bunch of data scientists say, yay, let's do this model. It's not start like this way. Usually like in a normal situation, there is a question, or it's competitive advantage, or it's speed to the market. So there could be different things, or you want to clarify something, or to predict something. The stakeholders, or at least I mean stakeholder for this specific project or let's say that project that wants to figure out something. So you start with this, and we always start this with like this exploratory phase, kind of what kind of data do we have? What kind of data is available?
Yeah.
Then you always talk to subject matter experts, like is this data says this? Is this data implies this? So in this case, I would not say that you need usually big data for it. No, sometimes it just could be not available. But at the same time, right now I see in the market shift to more, they call it like data-centric AI. So where for many years we were so focused on the models to get the models better, the models like this metrics better, this metrics better. Now it's not about this, now it's about how could we make data better.
Yeah.
But so just to sum up, so no, it's not needed to have big data for all use cases, but there are really specific use cases where you can't live without big data.
Okay.
So it depends.
So it really
literally
depends on,
Yeah, I agree 100% with that, right? So the model is just as good as its data. And I do sometimes think it's kind of continuum, right? So to find new data sources is obviously always great. But sometimes it's just practical. Take the data that you currently have, build a model on that, and then start enhancing it. And I do think you can go on the big data journey. You can spend a lot of money and a lot of time and a lot of effort, and then try and get a model developed in the next 18 months or 2 years. Whereas if you went a little bit more incremental and used the current data that you currently have, you could have a model up and running, and let's call it 3 months, 6 months. And then you can start building on top of that. And I think sometimes that's even better, right? Yeah. So, but once again, I think it ties down to what's the business question, right? What are you trying to do? What are you trying to solve for it? So, that makes sense.
Nice. All right. Well, we'll go to the audience question.
Sorry to interrupt. It's actually not a question in the sense of a question about the topic. It's a question about the sound. I'm going to fix your microphone because it's a little bit noisy. I come to try to
no problem.
better. Actually, it's the both of you that the microphone is noisy.
Okay. Yes.
Can I just leave it over here? I guess so. Let's just leave it over there.
Noisy data.
It's noisy
for you,
data.
And then you cannot use.
The cord is inside, right?
Yes.
I also want to recommend you to just to put it here.
All right.
And then fingers crossed that the sound is good now. We tested it, but
It just noisy data. It's okay. We're in production right now.
Noisy
right?
data.
That's a good one.
Okay.
Cool.
okay,
Better.
We'll see.
Okay,
cool.
We'll see.
Okay, cool.
Thank you.
Nice. Okay, then we'll go to a real question again and hope that the sound is better. I have a question here. What are the pillars to setting up a model and how much time do they take? So how is it distributed?
Yeah, I can maybe talk that from once again from more the statistical side. So typically when you build a model, 70% of your time is figuring out the data. Is it good? Can you use it for the model? Is it representative, etc.
Yeah.
Then the next 20% you kind of build the model, which is kind of the nice part, and then the last 10% is you need to document the model and get some external validation going on there. So it's by majority the largest part is data, right? And trying to figure that out. And I think it's really important because like garbage in, garbage out. Yeah. I do think if you have a very good data environment and you've got confidence in your data, that can be shrunk, right? That 70% can move down quite a lot. Mm-hmm. And because when you build models, it's typically highly skilled people building it. It's quite an expensive exercise. So if you can reduce that, I think you can reduce the cost of developing a model. But it also reduces your time to market, right, of a model. So you can shrink that, then you can start building a model quicker, and then you can start second generation, third generation type of model. So I think fixing the data for your model development and having a good data environment is kind of critical. Yeah. The other side of the coin is if it's wrong, that could create quite a lot of issues, right? So that last part, and especially in financial industries, there's a regulator that's looking at the models, there's internal validation. Sometimes the guys would build the model, they know there's a little bit of data deficiencies, but then that's picked up there, right at the end, or even at the regulator step. Mm-hmm. And then everybody needs to go all the way back, right? So I think having a very good data environment is critical, specifically for I think, it's called supervised machine learning, which typically is being used in the banks to a certain extent in the regulatory capital. I think it's even more important in the unsupervised learning model environment, right? So that's where you throw a lot of data into a model. I don't want to say black box, but it gives answers very quickly, and it's not always very explainable. Mm-hmm. So I think from that aspect, the data quality is probably even more important than in the supervised modeling process.
Yeah, exactly. I agree with you. The data quality, having a solid data platform that you can rely, and the data intensity is good, and also the data quality is very important and crucial. But next to that, I think it's very important to have good monitoring as well. Yes. So if you have model in production, you need to. Good monitoring can be done with alerts and logs, very specific to know every detail about the modeling. And if something goes wrong, you can define thresholds and get alerts for that. And you can also trace back to the training, which these scores are produced from which training. So then you have better idea about what's going on during the run, because this model can be either real time or batch processes, daily, weekly, monthly, or yearly. And so you need to make sure that the model is functioning well during the time, over time. And also, I think the other part is the reliability. So in the previous question, actually, we were just mentioning here a little bit, Aliona had mentioned a little bit, that I think the machine learning applications also needs to be approached as a software engineering project, software application. Yeah. So it needs to be applied all the software processes, like properly testing and deployment on the test, acceptance, and production. But of course, machine learning applications are more computational expensive applications, because it's a bit different than a traditional software. But this shouldn't prevent doing testing and integration testing, that to make sure that all the predictions and scores are actually produced correctly, and then you can rely on the project and getting. So when you move to production, that you know that your prediction is correct. But additionally to that, for having software engineering practices, very important to have CI/CD as well, continuous integration and continuous deployment. So basically, that's you have tests, but if you never run your tests and if you never use them, that doesn't add any value. Yeah. And it's always from my experience, I see from the engineer scientists, it's always like a bit extra work to execute that test. So to prevent this, actually, we can use CI/CD automated pipelines and then continuous deployments. Basically, with every code change you do to your code base, that is going to be tested, built, and deployed to your test environment, dev environment. And then you can make sure and rely on the application. Yeah. So I think in the long run, these are very important and crucial.
I agree.
Definitely.
Yeah, definitely.
Which these things you just mentioned make up a good base to start from something. And
exactly.
I have a question, and I'm scared for the answer. What if I do not have the time or the people to start from a good base? What happens? I'm scared for your answer.
Well, I think the question answers it itself. So it is actually a very bad thing to happen in an organization, because if you're spending on the money on a project and there's a person working for this to build this code, but afterwards, if it's not maintainable, you cannot continuously develop this application, and it doesn't bring any value to the business. So the goal is to solve some specific business problem or reach some specific business goal. And then if the model is going to work for a week, but afterwards, if there are some changes, some hard-coded values or something that are not very well taken care of, it's going to cost a lot more than building a good base. But whereas when you spend time to build a good base, and maybe it's going to look at the beginning that, this takes so much time, and are we gonna get it back? Are we gonna gain it back from this? But actually, it is like that, because at the end, you always see some restrictions if there's not a good base. Yeah.
Yeah. So. Definitely. Yeah.
And I think I just gonna add up to this. Usually what I see, like the best case scenario when you have, for example, data scientists, analysts, and other related people working on a vertical. So there are specific products, and you work on the products. It could be one model, it could be sequence of models, or any other constructions. So they do this work. And you have engineering that is go horizontal. So in this case, let's say engineering set up specific practices that could be automated and reused. So literally you spend some time on creation of this solid base.
Yes.
But then because it's simple, it's automated, it's maintainable, it means that every pillar, every vertical can reuse it, so they don't need to double their work. And it will cost you not 500 engineers at the end, it will cost you only 2 engineers. And that's the beauty of engineering. I always say, if you see something repeatable once, should I automate this? Probably not. If you see it twice, this is a really good candidate for it. And if it's 3 times, no comments, it should be automated.
Yeah.
And that's exactly a lot of things. I see it's really, really high value when there is automated data processes. So literally, specific product that you're working on, and there is literally a setup automated data fetching that delivers data that's necessary in a specific, really, really consistent way. Because when we're talking about model monitoring, there is sometimes, especially for time series model, they literally need to be retrained every time when you make a prediction.
Yes.
And for this, you need to make sure that there is a consistency in the data. So literally, the solid base is about setting up the processes and really good and nice software engineering practices. And then after that, let's say reuse it. And if there is some deviation from this scenario, you can just expand it.
Yeah.
But literally reuse it, because I think the worst thing that I saw when data scientists literally copying code base from one repository to another, then they change something in one, then another person changed theirs.
Chaos.
Yeah. Spaghetti.
It's not even spaghetti, it's even something much more complicated. But I would say, for any person, especially for business person who needs to take the decision, should we continue this way, yes or no? I would say focus on time constraints. Later, it's not about push, but understand that if the company never used this type of work before, there should be some investigation done and then setting up specific automation. And if the companies already use it, just to see what are the repetitive tasks, just to automate the specific repetitive task.
Yeah.
But if you don't do this, you will end up with thousands of models running in production without any monitoring, constant complaints, and sometimes it could be really dangerous for the business. I mean, really, really dangerous decisions. So it could be goodwill damage as well. It could be reputational damage for the company.
Exactly.
It could be financial damage, right?
I think
So in financial industry, if you decide you want to accept for a loan or not, if you get the wrong data going through there and you accept not such good risk customers, it's actually got a material impact, right? So, and even maybe on the capital side as well. So it is really, if you get it wrong, it's got material consequences.
Yeah, also security will be part of this too. In the platform, you have to keep your data secure and respect the GDPR and all these rules around it. So these are all like you can, if you build something is very flaky, and these are going to cost a lot of money at the end to the organization.
So don't rush it. And,
I would say experiment. Take it, with a
and keep testing.
Keep testing. Monitoring.
Yes, but think about it. Let's say what could be that. I really like things that call like pre-mortem, when you just sitting and brainstorming what could go worse and go south, and how you're gonna fix it.
Yeah.
It's really nice thing. You can use it like for any use cases. Do you want to start with AI? Do you want to start with statistical modeling? Do you want to start just with implementation of business rules? Whatever, it's applicable for any use case and scenario.
Yeah.
Usually.
Nice. Well, you kind of answered my next question. Because, you just told us what you need to set up a good base, which was, where do I start, was literally the next question. Do you have a summary, where do I start, just in one sentence? Maybe one sentence is too short.
No, I would say start with, why do you need this?
Yes.
Yeah, the question.
Yes, the question. Asking the why question.
Yeah.
Because we need to understand the business requirement. Why do we need this? And the how, it should be in the later stages to how you're going to implement this. But the important is why we are doing this.
Yeah, nice. Okay, great. So if you want to start, just ask yourself, why are we starting? Yeah, nice. Really. And then I have a question for you, Celine. I think it could be nice. What are the first steps during implementing a new model? Because we've been talking about how to start and make it a beautiful one, but how do you start implementing it?
First, of course, that we also mentioned a little bit to having the data available data, and make sure that data has enough data quality, and create metrics for this. And for data quality, make sure that there are no inconsistencies. So, and then you can start experimenting. And I would say that when building a model, it doesn't have to be started really a serious project, because it can come to that phase a little later. Usually, like how the traditional way is, like using notebooks, of course, experimenting with data, understanding the data, and afterward, but not very early phase, just start writing your unit tests for every function you're writing, and then you're creating a very solid, good application that can actually, from the first point, you need to think about that, how I can move to production if I have some good results now. Because sometimes I've seen that before, that these notebooks are built like a really long pages of notebooks, and the model now it's scoring nicely, and then the predictions are correct, and now we need to move to production. But then there is a really huge transition time from notebooks to this, if it's a Python project or Scala project, so to move to this proper deployable code package. And there it starts lots of questions from data scientists and then data engineers trying to fix all this base. But so I would say very early stage, start making a proper Python package. Let's say we are using Python, a proper Python package which can be deployable in the very first start of the project. And then you start, and then you're testing it, and then afterwards you can monitor it continuously.
Yeah, Nice. And then there is something out of nothing. Well, not out of nothing, out of good data, we know now. And then you want to build on it because you all told me you need to start somewhere, but then you want to make it bigger and make it better eventually. So I have a question here. I have a data model. Nice. How do I pick which functionality is next? What do I add? And when, maybe?
Well, I think it's part of the data exploration. So if you go through that whole development process where you, I think, prototype, right, and you build your first model, then explore what are the other data sources that you'd like to use. Test its viability and test its predictive power. And then it's kind of business case driven, right? So if you add these additional data elements, I'm getting a 10% increase in predictive power. Then it starts adding value, and then you can start investing and following the processes I think that they've mentioned to add those additional features and start incorporating that into the next generation model build. So that's from the modeling side how I would approach it is explore, test quickly, see if it adds value, and then bring it into the current infrastructure and fold and build a next generation.
Yeah,
model.
Iteration by iteration.
Yes.
Yeah. Don't start doing everything at once. Yeah, see the results and keep your stakeholders close. Make sure that the scores are correct and get constant feedback and develop by iteration.
Yes.
Yeah, very important.
Yeah, because I also have a question: is what are your experiences with implementing a new functionality in an already existing model? And well, I guess just add it slowly.
And then you can say like it depends if it was like properly packaged, let's say done. That is just like understanding what exactly should be added. Then you define where it should be added. Then you see how it performed. Then you can, for example, deploy models like in shadow mode. So literally, when you have the models that do predictions, then you have your model like the new updated, let's say expanded model. They just run in the shadow, literally of this model. And then just like doing the same prediction, then you can compare predictive power of like these two models, for example. So there's also like option doing things like this. But once again, it depends, because if it was really badly set up, if it was not reliable, not clear what kind of data, how the model, which version of data set was used for the model training, how the feature generation were working, how all these like steps were done, no documentation, the code is ugly, or just like pure notebooks that somehow just put somewhere, then good luck, I would say.
Yeah, definitely. The code should be idempotent so that you should be able to run again. But there were cases sometimes like data scientists build a model and running on production, let's say it's a monthly model, but he left the company. So now, and now we need to add a new feature for this model. And now how we're going to do it? I think it's a clean code, good documentation. If there's clean code and good documentation, this is not going to be a challenge. But if these are not there, it's going to take lots of time. Maybe it's going to you need to spend more money than that model brings to us. So these things need to be considered. Documentation very crucial.
And I do think that getting the data engineers early in the process. So I think modelers, I think by nature are explorative, right? So they'll say, we've got this new data source, and let's create a few new features, and they'll try this one, and then they'll try another one, and they'll try and change it, and eventually they'll find one. But if you look at, I think the code, it's obviously very explorative, right? So it's messy, typically. I'm a modeler, so I can talk about my stuff. And you do actually need to clean that up, right? And I think that's where you need to get it production ready. That's where the data engineers can kind of help with that process as well. Because, I think from modeling side, you can code it up to find which feature, but it's probably not necessarily the best way to do it. So I think from model execution performance, it's also a big benefit to get the data engineers earlier in the process.
Yeah, very important.
And put it through. So I do see it going forward to resolve that, to a certain extent, that mismatch. It's getting everybody, business, data engineers, modelers, and IT actually as well. So everybody as part of the project plan and moving it forward, because then everybody's aligned.
Also, I 100% agree with this point. And I think the code reviews are also very important in the sense that the early code reviews and also it's also nice that what code review, nice to know that all team knows what code review is. Maybe having a one template for code review so that everybody is at the same page, and then applying for all these models in the organization the same code review. That can actually gain a lot more in the early stages than data engineer reviews the code of data scientists, for example.
Yeah.
Then you can spot all these small problems very early stage.
Yeah. Which I'm gathering is small problems in the beginning.
It's going to
snowball. It snowballs.
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 Yeah,
Yeah.
Okay, nice. I see another question, I hope this time, from the audience.
How are the microphones?
Yes, out the microphones. Yeah.
Luckily, no technical issue.
Okay.
I know the sound is still not optimal, but actually there is a real question. Does any one of you of the panel have a story about a model that was implemented that created a huge amount of value for the business? It's a question from Thomas.
I'm trying to figure the exact one. Yeah, I can maybe talk. Many years ago, we were looking at, still in the South African market, so it wasn't big GDPR, so it was outbound prospecting models to target who you would like to, offer some kind of financial product, specifically in this case, credit cards. And I had no models, and then we started implementing quite advanced models to target exactly the right person, because previously it was just, we send out emails to everybody or we phone everybody, and we started applying those models. And I think towards the end of the model, or the few of the generation of models that we implemented, those models were responsible for 40% of new business. Where previously 90% was coming through what we call the branch channel or not outbound prospecting, and it was actually a massive revenue generator for the business. So that I think that's kind of the one. And then some of the other models we add additional data features. I've seen where the predictive power relatively increases by like 30%, which obviously has a big impact on the P&L. But I think that marketing one was probably the best one, where over time it actually was generating a lot of value for the business. And also, it depends how you look at it, but it was also a little bit more helping the customer as well. So rather than you getting mail and it's absolutely not relevant to you, it's now actually specific because you probably would want that. So I think that's the one that comes top of mind.
Nice one. Yeah.
I don't know.
Yeah, I think I can adapt to. So there was a really interesting project. It was literally like really expensive project, because the idea was literally to pick up your bank account records, and the goal was to classify your bank account records to specific costs. So for example, if you see like this is a parking cost, then you can tag it like a parking. If it's, for example, like food, then you can tag it like administrative cost, like for food, something like this. So the problem was first because there was when you look at the accounts, a bank account, every description is really limited. It's usually like just small, let's say, abbreviations. So you need to understand how these abbreviations could be interpreted. On top of it, there were a lot of things in Dutch language, whereby for Dutch language, there is not so much work done as done, for example, for English. And the question was like pretty expensive and big, huge model. It was a deep neural network. It was like designed together with linguistic people who has knowledge on this specific accounted terms in Dutch. And from one side, it was like looking like it cost like every run of this model, it was like cost like really huge amount of money, but it's all relative because when it starts working, so it was actually at the end like the model that was classifying something like 955 different types of costs. So for those people who were literally offering accounting services, the time to fill in all the documents were literally gone from, let's say, 2 hours to 15 minutes. So you just get, let's say, like some suggestions. This cost, it's probably this type of cost, it's probably this type of cost. So you know how to book cost to which title. So literally from one side, it was sounded like really huge and expensive project, but the amount of value that it brought to the company and amount of value for all these accountants using the software of this company was so huge that they decided to invest even more to see, let's say, what other things could be improved. So from one side, sometimes it could really like sound like 50,000 euro for one training run. It just sounds like really expensive. But then the value that you can get out of it, it could be like in millions, literally.
Yeah.
So I think it's one of the biggest, literally, like value gainers that I saw in my career in comparison to the others. Like if we're talking about financial industry.
Awesome. Cool. And Celine, do you have one?
Well, we have many models, of course. And one of them was when we build a project, a platform where actually data analysts can create queries and automatically. You can think of it like a BigQuery. And this is this generic project that data analysts can provide recipes with which tables they want to use and what they want to get out of it. And this is basically a factory that generates all these models. So that actually extended the data analysts. They didn't need to write actually a code, and they just need to provide some simple files, and that the name of the tables, what kind of data they want to use, and then afterwards the predictions and the model is going to be automatically generated from this factory project, and that actually saved a lot of time for data analysts and also for the organization. Of course, it's a cool project.
Cool, awesome. Yeah, awesome. Great values. I see the time is going by very fast because we're having a lot of fun. And I have a question I think would be a nice one to end on, and would be nice to follow up this one, because now we've talked about which brought the most value and which was something you were very proud of. We talked about struggles. So do you all have one in mind that was the biggest challenge for you? That you ran into?
Not a specific example. I think there were a few in it, but it is a struggle, and I think we mentioned it previously. It's when the data that you've built on is not the same as what you want to implement it on, right? So, so I think, and I think that's happened a few times, but it's also just the disappointment around it, to be perfectly honest, right? So I think the whole concept of getting everybody together in the earlier stage, and a model, once you've built it, it's basically a piece of code, right? If it's not running for the business, answering the business question, it doesn't really mean anything. So, so I think that's one of the biggest struggles that I've seen through my career around, deploying and building models.
It comes back multiple times.
Yeah. I can say the same thing actually, because that's the biggest challenge. And if your development environment is not the same as production environment, and you're going to get totally different results. And sometimes that the engineer, data scientists, or like the developers, they are building the code based on this development environment, and that could be something wrong with the code, or the data could be different. And when you move to production, actually you're seeing that it's not working, and then you need to go back to start from there again. So I think keeping this environment similar, and especially if you have on-premise environment, that's very important. And I think the other challenge is that the limitations of the platform. So, and in now modern cloud infrastructure, so it can scale easily, but not always on-premise clusters, because there are this physical breaks, and then adding an additional node. Let's say you have a distributed data platform like Hadoop, and adding additional physical machine there would be take some time. It's not exactly like
it's not like switch it on,
right? Switch it on. So this kind of things that you need to keep your model's performance very well, and you need to keep monitoring how long do they take, and do you have enough space, and do you have enough resources to run all these models. And so that's also a really important part of a big challenge, and it requires a really good code review, configurations, and monitoring especially.
Nice.
And I think I will just jump on straight on the monitoring, because I would say monitoring is really, really crucial. I mentioned at the beginning that the model usually is not static and the predictions are as good as the data that come in the model. But I would say I really see often, especially in an enterprise setup, there is no time for monitoring. We're going to build, we're going to deploy, monitoring will come later. And trust me, every time you say it would come later, you're just increasing this pile of garbage and it's making it bigger, bigger, bigger. And I would say the biggest challenge is actually to set up first just a basic monitoring, just literally basic, just to know whether like this compute is available, like storage is available, there is no issue with network. And after that, to introduce as fast as possible just basic, for example, statistical checks on the data. So we can measure data drift. So it's like literally how the data changes, incoming data changes. We can also monitor prediction, like target drift. Let's say what the model is predicting, whether it's staying specific. Like if you're predicting 0, 1, you don't expect to get 5, for example. If you're predicting between 0 and 1,000, you don't expect to see 2 millions, for example. So if something is going up, that's exactly immediately alerting system, like there is some threshold, you need to react on it. But the hugest struggle here, I see a lot of hybrid setup. For example, when you have data on-prem, because the data are really, really sensitive, you're not allowed to move them to the cloud. Then you have the model that is eventually in the cloud environment. So in the cloud, because like there is no compute available on-prem for it. And then the question how to set up monitoring specifically to the model, because you don't have opportunity to keep data in the cloud. And this is a huge challenge. Then you start, let's say, adding, okay, should I run data drift on-prem? Should I run these things on-prem? But I would say the biggest challenge is to make sure and to say everyone, especially a lot of people in the IT world, they do not understand how the monitoring for the model is different from just simple, let's say, software monitoring. It's just to prove them how crucial it is. Because so far, the biggest, let's say, use cases that you used to work on, we always start with the situation that business people, users start complaining that the model produced garbage, and then we go backwards to investigate logs, then we go backwards to investigate, instead of just having really basic rudimentary setup for monitoring. So I would say, for me, if it's about modeling, monitoring is the first step that I would love to introduce, even before test.
Nice. I love how I asked you about a challenge, you gave one, and then you spit out the solution right after. I love it. Thank you so much. Well, that's the time for now that we have today. I want to thank you all. Thank you so much for being here. And I can definitely say that I know a little bit more about data. Trust me, I didn't know much coming into this, so that was very nice. And I want to thank everybody who watched from home, and I hope you also learned a little bit. And then I hope to see you next time in Studio LINKIT.
Cool. Thank you. Cheers. Bye. Bye, everybody. Thanks for hosting.
Thanks for hosting.